All right, we're continuing with 6.5 here, talking about inequalities in a single triangle, and then starting off with a theorem, theorem 6.9, the triangle longer side theorem. What the triangle longer side theorem states is, in a single triangle, if you have one side that's longer than a second side, then the angle opposite that longer side is larger than the angle opposite the shorter side. For example, here's my triangle ABC. Let's just say AB is 6 units in length, BC is 4 units in length. Then since AB is longer than side BC, the angle opposite side AB, so in this case angle C, measure of angle C, has to be greater than the angle opposite the shorter side. So the measure of angle C is greater than the measure of angle A. That's what the triangle longer side theorem states. So I just wrote out the triangle longer side theorem, everything that we just talked about. In this triangle here, if I have the length of the third side, AC, let's just say that's 7. And then I can order each of these angles from either largest to smallest or smallest to largest. The measure of angle C is still larger than the measure of angle A, but since side AC is longer than side AB, the measure of angle B, which is opposite the longest side here, would be the largest angle. So I could add that in right here. Measure of angle B would be larger than the measure of angle C. The measure of angle C would be larger than the measure of angle A. And then by the transitive property, the measure of angle B would also be larger than the measure of angle A. And then for theorem 6.10, the triangle larger angle theorem, it's similar to the triangle longer side theorem, but if you have a triangle, I'll call this triangle PQR. Now, if you know the measure of the angles, so let's just say the measure of angle P is 50 degrees, measure of angle R is 30 degrees. So it's definitely true that the measure of angle P is larger than the measure of angle R. Then what the triangle larger angle theorem states is the side opposite the larger angle is longer than the side opposite the smaller angle. So I typed out the triangle larger angle theorem, and we can kind of combine a couple of theorems here in order to be able to write an inequality about all the sides in the triangle. So if I use the triangle angle sum theorem for this, the measure of angle P is 50 degrees, the measure of angle R is 30. So if you subtract those from 180 degrees, that leaves the measure of angle Q is 100 degrees. All three of these angles add up to 180 degrees. Then I could order each of the sides from either largest to smallest, longest to shortest, or the other way around, shortest to longest. It just depends on the directions. But the length of QR, well, actually, let's start with the longest side. So the longest side would be opposite the largest angle. Largest angle in that diagram is angle Q. So the longest side would be PR. This is the length of PR. The length of PR would be greater than the middle side, which would be opposite the middle angle. 50 degrees is the middle angle there. So the middle side would be side QR. And then the shortest side would be side QP or PQ. So this is ordering each of the sides from longest to shortest, using specifically an inequality. And then the last theorem for our 6.5 is theorem 6.10, the triangle inequality theorem. So if you take a single triangle, call it triangle ABC, the sum of the lengths of any two sides of the triangle has to be greater than the third side. So it doesn't matter what two sides you take. I could take AB, that length, plus BC. That's the sum of the lengths of two sides of the triangle. That has to be greater than the length of the third side. So the length of AB plus the length of AC. BC has to be greater than the length of AC. That's one inequality that I could write for the triangle inequality theorem. I could take the length of AB plus the length of AC, again, that's the sum of the length of two sides of a triangle. That has to be greater than the third side, BC. Or there's one other inequality that you could write. Possibly pause the video and then see what inequality that could be. Okay, if you said the length of BC plus the length of AC, that has to be greater than the length of AB, that would be correct. So that always has to be true for any triangle that you have.